Alright, why are we even looking at an eye? What are we doing here? Well, the reason we're looking at this eye is because eyes are something that dilate, and that is what we're talking about in this lesson, dilation. You see, pupils dilate, meaning they get smaller or bigger to let more or less light in. As you can see here, see pupils getting smaller, getting bigger, smaller, bigger, and that's a dilation. So we're going to be talking about the same thing today, but in geometry. So what is a dilation? Well, it's just like with the eye. A dilation is a transformation that produces an image that is the same shape as the original, but a different size. So the pupil stays a circle, right? But the size of it's changing. So that's what a dilation is. So there's two important things in a dilation, the scale factor and the center of dilation. These are the two things that every dilation must have. The scale factor is the factor by which the length is multiplied by. So if the scale factor is 2, everything's increasing by 2, all right? Or like multiplied by 2. And the center of dilation is a fixed point about which all the points are expanded or contracted. So if things are being multiplied by 2, the center of dilation is where they're moving away from. All right, so let's take a look at an example here. That may make more sense. So in our example over here, we have point P. All right, we want to draw P prime after a dilation centered at point O with a scale factor of 3. Now, I'm going to pause the video for 1 second, or you're going to pause it so you go get a ruler, because a ruler is necessary right now for this lesson. Go get your ruler, okay? Alright, so the way you do a dilation, alright, we're going to draw a dilation of P prime. So you can take your ruler, start at the center of dilation, which is O in this case. You're going to put your ruler right against the line, okay? Now, what you can see here is that O is 2 centimeters away from P. Now, it's different on your paper because when it copies, it changes all the measurements. So just ignore your paper for now. We're just going to write this down. We know that OP is 2 centimeters, alright? Now that we know that, I'm just going to move the ruler for 2 seconds. All right. The way that we're going to find out where P prime is, all right, we have to multiply that by the scale factor. So just to give it to you in a formula way, 3 times our original length, 3 times OP, will give us the length that we need. So we know that 3 times OP is 2, is going to be what OP prime is. All right. And so that tells us that it has to be 6 away. So that's all we did. We just multiplied it by the scale factor. So we go back to our ruler, and now we're going to measure 6 away. So P prime has to be here. That's going to be our new point, right? All right. Take our ruler off, and we just label this P prime. And this length is 6 centimeters. Alright, so a scale factor is just what you multiply the length by. The center of dilation is where you start, and that's where things move away from. And that's the main information. Alright, for our second problem, we're going to draw a triangle ABC after a dilation centered at point G and a scale factor of 2. So if you notice here, there's our two main pieces of information. We have our center of dilation, and we have our scale factor. Always need those. That's clutch. Now the way we're going to do this, alright, and you're going to learn, is that you put your ruler and you start it at the center of dilation, which is at G, right? And then you're going to measure the distance away from each of the points, all right? As you can see here, you have your steps. So let's measure this all right? So let's see. When we measure G to A, that is 3. Now, also while you're doing this, why don't you draw a nice dotted line to go along with it? You'll see why this comes in handy. So you just draw a dotted line like so, along this line. And then we're going to label GA is 3. Okay. Now we're going to go down. We're going to do the same thing. When we go down, we see that GB is also just about 3, so we're going to call it 3. All right. Draw our dotted line. Like I said, you'll see why this comes in handy. We're going to call this also. This is also 3. Right? And then we do our final point C, which is just about 4.5 right here, right? That's about 4.5. So we draw our dotted line. All right. And that is 4.5 from G to C right here. Now, that we got our originals, we have to dilate it, right, using our scale factor. So everything is multiplied by the scale factor, which in this case is 2. All right? So you do 2 times GA, right? And that gives you what GA prime is. All right? You do 2 times GB, which gives you what GB prime is. And you do 2 times GC, which gives you what GC prime is. All right? So let's multiply all of these by 2. So our first one, GA, is 3, so it's going to be 6 away now, right? 2 times 3, we do the scale factor times the length. So we put our new point right on the line, but now it is over here. All right? This is going to be A prime. We're going to move over here. Multiply once again by the scale factor. The scale factor is 2, so 3 times 2 is 6. Alright, put this over here. This is our B prime. Alright, and then we go to our final one, which was 4.5. 4.5 times 2 is 9, so that goes over here, and that is our C prime. Okay, let's connect up these new points like so. Make them nice and pretty. Use your ruler. And looks like so. And if you notice, when you do it this way, these two triangles have the same exact shape, but A prime, B prime, C prime is just twice as big as it is before. All right? And that's how it's done. That's how you dilate. All right? Now another important point to realize here is that the lengths of all the sides of this triangle are twice as big as the lengths in our pre-image, okay? So if the scale factor is 2, all the side lengths also increase by 2. So 2 times AB would tell us what A prime B prime is. 2 times BC would tell us what B prime C prime is, and 2 times CA would tell us what C prime A prime is. If you aren't fully getting me, I'll just give you an example. Let's say we knew that AC was 5, all right? That would just mean that A prime, C prime is 10. All right? Now, I don't have that, but that's how it goes. Could also measure it, but we know it's true. Okay, so that is how you draw a dilation. Now let's move to the coordinate plane. All right, so now that we're on the coordinate plane, we know that triangle ABC has point A at -3, 1, B at 4, 2, and C 1, 4. What are the coordinates of triangle ABC after a dilation, centered at the origin, and with a scale factor of 2. All right, so we have our two most important pieces of information, where our dilation is centered at and where our scale factor is. Now, quick vocabulary. Does anyone remember what the word origin means? Write it down if you know. Maybe pause the video. I'll tell you though, it is at 0, 0. Origin means 0, 0. All right, so to do this problem, let's start by graphing ABC. So A is at -3, 1. That's A. B is at 4, 2, and C is at 1, 4. Okay. Let's draw out our lines, connecting everything, and now we got ourselves a pretty triangle. That is the prettiest triangle in the whole wide world. Maybe not. I'm just being nice to myself. Don't say nothing. All right. To dilate it, we're going to start at our center of dilation, which is at 0, 0. We're going to mark that. It is at 0, 0. And the way you do it is you just count. So watch how you do it. So from the center of dilation to A, we just count how we get there. So we go over 1, 2, 3, and up 1. We go over 3, up 1. If we are dilating by 2, that means we just do that twice, meaning we're multiplying that distance twice. So A prime would be at, we're going to do this twice. 1, 2, 3, up 1. That's the first time. And we're going to just do it again. 1, 2, 3, up 1. And that is our A prime. See, by doing that twice, you've doubled the distance. Let's try that again for B. So to get to B, we go over 1, 2, 3, 4, up 2. All right, we go over 4, up 2. Let's do that twice now. 1, 2, 3, 4, up 2. 1, 2, 3, 4, up 2. And that is our B prime. And C prime, let's count it. 1, 2, 3, 4, 1. So up 4 over 1. We got to do that twice now. 1, 2, 3, 4, up 1. 1, 2, 3, 4, up 1. And that is C prime. Okay, we got our new triangle. We got our image. Let's connect all the points and blam. There we go. Now the question here is asking us to state the coordinates, so let's be nice enough to do that. ABC, that is given to us, so that's at -3, 1, 4, 2, and 1, 4. Our new coordinates are going to be at -6, 2. Alright, just finding out where they are. This is at 8, 4. B is at 8, 4, B prime, and C prime is at, let's see, 2, 8. Alright. And that's just how it's done. It's just a counting method. Alright? Now, is this a rigid transformation? You should know this by now. That is a resounding no. Why? Because the size doesn't seem the same. Remember, that's what a rigid transformation is. But we're going to use the fancy language. We're going to say the distance between points is not preserved. Right? And that makes sense because look at AB. This is AB right here. It has now doubled in size. The distance between these points has not been preserved. Sorry, not a rigid transformation. Alright, let's try another one that's not centered at the origin, okay? This gets a little trickier. XY has points -5, -1. So 1, 2, 3, 4, 5, -5, -1. Alright, that is our X. And we have our Y at -1, -4. Wait, 1, 2, 3, 4. Why am I graphing so bad today? What is up with that? Alright, 5, -5, -1. X, Y is -1, -4. There's our Y. We're going to connect that with a nice line. Okay? Now, we're going to state the coordinates of x prime, y prime after a dilation centered at P, which is at -6, -5, with a scale factor of 3. So our center of dilation is not in the origin now, is changed to -6, -5, which is right here, and has a scale factor of 3, meaning I'm going to count this by 3. Same thing, we're just going to try it all over again, okay? So how do we do it? We just count. But now our scale factor is 3, so we're going to do things 3 times. So to get to x, so if P is right here, alright, let's count the distance. So from P to x, it's 1, 2, 3, 4, up 4 over 1. We just got to do that 3 times now. So 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1. And that is where P is. Where our x prime is going to be. Now we gotta get our y prime, okay? So let's count it out. So we go over 1, 2, 3, 4, 5, up 1. So now we're just gonna do that 3 times because that's our scale factor. So 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5, up 1. 1, 2, 3, 4, 5, up 1. And that is our y prime. Let's connect that with a nice looking line. Kapow! And we did it. That's it. That is our dilation. So our x coordinates, we know we're at -5, -1, and y is -1, -4. Our new x prime has moved to, let's see, 1, 2, 3, -3, up 1, 2, 3, 4, 5, 6, 7. -3, 7, and our y is at, let's see, that's 9 down 2. It's going to be 9, -2. Beautiful. Now we're going to fill in the missing information here, okay? Now here's what you got to know. XY, the length of XY is just 3 times our original line. So 3 times XY gives us x prime, y prime. That's after dilation. We also know that the distance from P to x times 3 will give us px prime. So 3 times px gives us px prime. And then also 3 times py, alright, will give us py prime. Remember, from p to y to y prime is going to be just 3 times as long. Alright, this lesson's getting a little long. I never want to go over 15 minutes, but it's happening. Final part of this lesson. We're going to find out how to find the scale factor if it is unknown. Alright, pretty straightforward. To find the scale factor, you just divide the length of the image by the length of the pre-image. Alright, that will tell you how much the scale factor was. So the way we usually denote the scale factor is using k. Alright, and it's just the image divided by the pre-image, these lengths. Let's give it a shot right here, okay? Oh, where'd my points go? Find the scale factor if OP prime is 16. Okay, we know this length is 16. And OP is 4. So, what is the length of our image? That goes on top. The image is going to be the prime, so that is OP. Okay? And then what is the length of our pre-image, which is OP? Alright? We're just going to use that. Image over pre-image. So now we just plug in the lengths, which we know are 16 over 4. 16 divided by 4 is 4. Our scale factor, that means, is 4. Let's write down our answer nice and clear. K equals 4. We just did that by dividing the length of the image over the length of the pre-image. Simple stuff here. We got it. We got this. So a dilation center to E is shown on the graph below. The image is A prime, B prime. What is the scale factor of this dilation? Let's do this. So there's 2 different ways to do it, and you have to know both. So let's do it both ways. First way, we just do as I just showed you. It is the pre-image, sorry, the image, which in this case is A prime, B prime, over the pre-image. So it's the image over the pre-image. So in this case, we know it's going to be A prime, B prime. Let's keep our colors consistent here. A prime, B prime over AB. Alright? We just count. Let's get these lengths down. Well, AB is, the length is 3, and A prime, B prime is 3, AB is 6. Okay? So let's just plug in those numbers. So K is going to be equal to 3 over 6. If you can just reduce this fraction, give it a shot, it is 1/2. Okay, so that is our scale factor. The scale factor is 1/2. I want to write that again. K is 1/2. Alright, K, remember, is the letter we use for scale factor. Now, there's 2 ways to do this, okay? That's one way. Another way is to find the distance from E to each of the points. Alright, and what I mean by that is this. We do the same exact method. So in this case, what we're going to do is the distance from E to the image, which is EA, alright? And then we're going to put that over the distance from E to the pre-image, which is here, alright? So it's going to be, just to show you, EA prime, okay, the distance from the center of dilation to our image, remember the image is always on top, to, on top of our center of dilation to our pre-image, alright? So in this case, our distance is 1, 2, 3, 4, alright? So let's put that on top. And this distance from E to A is 1, 2, 3, 4, 5, 6, 7, 8, which is 8. And once again, 4 over 8 is 1/2, and you get the same answer. So 2 ways to do it, you get the same answer either way. We could have also done that by finding these distances, E to B prime over EB. Alright, that also works. So you could also do E over B prime over EB. So, that's the different ways to do it. This lesson's insanely long, sorry about that, but I think you got it now. So just go take a mental break, settle down, get yourself a glass of water. Unless you're in my class, then you need to chill and sit down and maybe do your work. But still, well done. You're a star.